Hey guys, this is for our second class for class 911. This is for either Wednesday night for my Monday, Wednesday class or Thursday for my Tuesday, Thursday class. So hopefully you guys received my PowerPoint, and you don't necessarily have to print off the PowerPoint, but I do recommend that you print off the practice problems so you can solve those along with me. Please make sure you join me live at 7 o'clock tonight after class. See if you have any questions. And also we just need to talk about a few things. All right, so here we go. The first slide should be the study skills lesson that you had, which is tips for success in a math course. So everyone should have this book. You have to get 10 grades for study skills. So make sure you follow the directions to get your points for your study skills class. So basically, once you read this article, which is on Roman numeral 5 in your book, the things that stand out to me for being successful in a math course is to make sure you read your textbook and your workbook. Make sure you take notes, even off the videos. Taking notes is very important. Make sure you review. As soon as class is over, the best time to do your homework is right after class. So don't wait until the end of Unit 1 and try to get all your homework done. It will absolutely overwhelm you. Make sure you stay organized. Make sure you have a calendar. You have all your due dates in there. You have your test due dates. You have all of that stuff available on Blackboard. So make sure you're staying organized. You use study aids. Make sure you practice. There are great practice problems throughout this workbook that you have in your hand. So make sure you're going through those problems and that you're practicing those on your own. Do your homework. You have to do your homework. You cannot pass this class if you don't do your homework. Understand, don't memorize. That's more for other classes than math, but you definitely can, make that a focus in math as well. Make sure you study and manage your time well. So Monday, I have these slides in the wrong order, obviously. Monday, you should have gotten your first, or Tuesday, you should have gotten your first grade for the first study skills when we had a live class. So as far as your second grade for your study skills lesson, make sure you have signed up for my remind.com. You can do that by either texting the number 81018 and sending the message at Lanier 911B, or you can simply go to that website there on the screen. And there are 2 questions that you need to ask over that article that we just reviewed and hopefully you read on your own. You need to send me these 2 answers. Based on your schedule, what are the best times and places for you to study for this class? Describe your method of taking notes. List 2 ways to improve your method. So make sure you send me those answers by Monday, which is Martin Luther King Jr. Day. So for my Monday class, we won't actually meet that day, but I need everyone in both classes. I need everyone's answers by Monday. All right, when you sign up for Remind, hopefully you did put your name when you signed up, so I will know who you are. Make sure I have your first and last name, please, so I can give you credit for those answers. All right, so we're going to jump right in. There's different types of numbers that you should be familiar with. The first definition or first term that we're going to talk about are natural numbers. So when you were just a little one and your mommy was teaching you how to count, those are natural numbers, the counting numbers. So if you were counting your M&Ms, you never started with the number 0, right? You just always started with the number 1. And so those are natural numbers, counting numbers, so all whole numbers besides the number 0. But then when we talk about whole numbers, that's when we throw in the number 0. So natural numbers and whole numbers are almost the same exact set of numbers. The only difference is whole numbers includes the number 0. So integers are all whole numbers, which are your counting numbers, and 0, plus their opposites. So 1, the opposite of 1 is -1, 2, -2, 3, -3. So when we're talking about integers, we're not talking about, that does not include decimals or fractions. So you need to be familiar with that term. Another way of looking at it is this: it's the set of all natural numbers, their negatives, and 0. And that's showing the list. Of course, we could list to integers forever, right? There's no end. All right, now the other thing you need to be familiar with are your inequality symbols. So the first one is the less than symbol. So when you were in elementary school a long time ago, you learned that the alligator mouth is going to be eating the bigger number. So that first symbol that way is less than, and then we go this way and it's greater than. Now, when they put a line underneath the less than sign, you would say that A is less than or equal to B. They can be the same number, or A is any number less than B. All right, the third at the bottom, the third, the way we read that is greater than. You would say B is greater than A. And then we could also have, oh, I skipped the last symbol. We could also add that or equal to sign under greater than or equal to. So you need to be familiar with those, and you need to know that when you're looking at it this way, of course, I don't know if I'm opposite from you. I don't know if I'm doing that in the right order by what you're looking at. I don't know if it's a mirror image, but anyway, you need to be able to recognize less than and equal to. So today we're going to talk about set builder notation. So we have this complicated looking thing here in blue. This notation is used to describe a set of real numbers, all of which have the property P, whatever that is. This can be read as the set of all real numbers X having property P. That line, the second symbol past the squiggly marks, can also be read as such that. So we could read that also as the set of all real numbers X such that X has property P. Now, what does all of that mean? Well, let's look at some examples. So let's look at example A. X is an even number. It's a more precise way of describing the set of, so think about even numbers, 2, 4, 6, 8, but integers also include negative numbers. So do you see the ... at the beginning? That means that we are not starting at the beginning. This does not include all solutions. So they showed an example of -4, -2, 0, 2, 4. And the reason they're listing them individually is because they can't say that it ranges from -4 to +4, because between -4 and +4, there are a lot of decimals and fractions. And remember, integers are only whole numbers, they're opposites and 0. So basically they're listing an example of even numbers, but they're using the ... to show you this is not a complete set. Now look at letter B though. It is saying that X is an integer such that -3 is less than and equal to X is less than 2. So we're talking once again of specific numbers because they're integers, no decimals or fractions. So they're listing all the numbers from -3 up to 2. Now, the reason they don't list 2 is because X is less than 2, but if you notice, it doesn't have the or equal to sign. So remember, we talked about an or equal to sign. This is missing, right? So X could be 1.9, 1.99, but X cannot be 2. It doesn't include 2, right? All right, let's look at letter C. C says y is greater than 1 and y is less than or equal to -4, which means that is an empty set. So there's no number that that set has in common. Either y is greater than 1 and y is less than or equal to -4. There's no numbers that make both of those statements true. All right, let's look at some examples that we can work with. Well, first though, we have to figure out when we're writing interval notation, sometimes we're going to use parentheses and sometimes we're going to use brackets. All right, so the first one we're using parentheses, the second one we're using brackets. Why? Well, it's because if you look at that less than or greater than symbol, these are lacking the or equal to symbol. So if you do not see an or equal to symbol, you write parentheses. If you see an or equal to symbol, you include the brackets, okay? Now this one, the third one, the one on the left does not have the or equal to, so we start off with parentheses. For the B, we have less than or equal to B, and so that's where our bracket comes from. And I know this is confusing, but when we start looking at examples, you're going to understand what I'm trying to say, okay? You're also going to use the symbols infinity and also negative infinity. As in, you know, positive infinity is all positive whole numbers or positive numbers, and negative infinity includes all negative numbers and forever that way on the number line, right? So anytime you're using infinity or negative infinity, you always use parentheses. Always use parentheses. So on your notes, so you guys, hopefully you printed off your note page that I sent you, right? Somewhere, I stuck mine on the bottom down here, not very neat, but I want you guys to write this in your notes. I want you to write that negative infinity, less than, greater than, and positive infinity get parentheses. And then I want you to make sure you realize that less than or equal to, and also greater than or equal to gets brackets. Keep those in your notes because we're going to start using those. All right, so how are we going to write what is being shown here? We're going to write the following as an interval using interval notation. So basically, this right here is saying, I'm going to change colors. So if I wrote my variable first, and I got to make sure the big part of my inequality symbol is pointing to my X, basically saying, this is showing me that X, in other words, an unknown number is greater than 11. So if we have a number line, 10 would be to the left of 11, 12 would be to the right of 11. I don't know what X is, but I know that it's a number greater, any number greater than 11. In other words, any number that's to the right of 11 on a number line would make this inequality true. For example, if I plugged in 13 there, that's true. 13 is greater than 11. If I plugged in 12, 12 is greater than 11. Now, if you noticed, I put an open circle here because it doesn't say that X is equal to 11, right? It's not equal to 11, it's only greater than, which means it could be 11.1, 11.5, 12, but it can't be 11. Now 10 is not included in my solution set because 10 is not greater than 11. So that means that X could be starting from 11, but not including 11. It can be any number to the right of 11. So in other words, that would go on for eternity, right? We could have 1,000,000, we could have 1,000, we could have whatever. So because we do not have the equal to symbol, we started with a parentheses, and on the right side, since we used infinity, we ended with a parentheses symbol. All right. Oh, think of this as X is greater than 11, but 11 is not included. And then same thing with the other two. So this one right here, X is greater than -3, but -3 is not included because it doesn't have the or equal to symbol. And the third one, think of this as X is between, look how X is sitting between -11 and -6. All right, so let's look at the second one. Let's graph that. So if we wrote the X first, X is greater than -3. So on a number line, here's my -3. It's not included, it's an open circle, but it's greater than. In other words, it can be greater or can be any number to the right of 3 on the number line. All right, any of these numbers. All right, and then let's go ahead and put the last one on a graph. And with graphs, you always want to put those numbers in numerical order. So -11 would be down there, -6, 0 would be up here somewhere, correct? So X is literally between, you can see that X is between -11, but it doesn't include -11 because there's no or equal to symbol, and -6, but it includes -6. So we're going to fill in that circle, and then we're going to fill in everything between -11 and -6. So now, how are we going to write those? Oh, I already did the first one for you. I can figure out how to, there we go. So from 11 to infinity. Number 2, from -3 to infinity. And then look at number 3's answer. From -11, there's our parenthesis because it's not or equal to -6. And it's got the bracket because we see that or equal to symbol there. All right, let me get rid of all my writings so you can see the answers there. All right, now we're going to write the set described by, so ignore 5x for a second. So x is an integer and x is between -3 and -2. So -3 is smaller than -2. And we see the equal to symbols. Now, I would normally draw a line here saying everything between this, but this is an integer. Integers are not decimals or fractions, so we are only talking about those specific numbers. Now, if we were going to graph everything we see except for the 5x, this is what it would look like. However, now it's telling us whatever x is, we're going to multiply by 5. So what is 5 times -3? And we only have 2 numbers in our solution set. So we're not writing like it ranges from, we're writing our 2 specific answers because there's only 2 included in our solution set. So 5 times -3 is -15, and 5 times -2 is -10. And that's our entire set. It doesn't range between those numbers, so we're not using parentheses and brackets because there's 2 specific answers because of the word integer. Now look at number 2. Number 2 doesn't have the word integer, so it can include a range of numbers from -6 through, or -1 through +6. So let's write it on a number line first. So always put your number line in numerical order. -1 and +6. Now, do we do an open or closed circle here? We do closed because of the or equal to sign. Do we do open or closed circle here? We do closed because the or equal to sign. And x is between anything between those 2 numbers, including fractions and decimals, because it doesn't say the word integer. Now, how do we write this? How do we write this set of numbers? There's more than 2 answers. Number 1 only has exactly 2 solutions, but we have a whole range of numbers from -1. Why do we write the bracket? Because of the or equal to symbol, through 6, including 6. And there's our bracket. Number 3, write the set described by. All right, now once again, do you see the word integer? That means we have to write the specific solutions. It's not a range of numbers because a range of numbers includes decimals and fractions. So first of all, let's write our number line. We're going to put it in numerical order. There's -2. Here's 3. Open or close circles. Close because the or equal to symbols. X is between those 2 numbers. Well, technically, I shouldn't have done that because these are integers. I should ignore that line and let's say, okay, well, if it's integers, it has to be between -2, -1, 0, 1, 2, 3. So since it's specific solutions and not a range, we got to do our little squiggly symbol. Now, if that 4x wasn't there, we would have our answer here. We would just list out these numbers. But now we're going to multiply our solutions by 4. So 4 times -2 is -8. 4 times -1 is -4. 4 times 0, 4 times 1, 4 times 2, whoops, and 4 times 3. And those are our exact answers because of the word integer. We can't have a range of numbers, it's only specific solutions. Oh. All right, -15 and 10. Is that all I had? I didn't have the other answers. Okay. All right, so now it's time to practice. So I would love for you to turn off the video and try these on your own, and then come back to the video and see if you wrote them correctly. All right, so practice number 1, write the following as an interval using interval notation. So first off, I always like to see a number line so I can figure out, well, let's see what it shows me on the number line. So if I rewrote this, if I wrote X, make sure the small point is pointing toward the X. X is less than 5. Now this time X is less than 5. And does it include 5? No, it does not. So X can be anything to the left of 5 on a number line. So what's down here? If we go forever to the left, what's down here? Well, that's -infinity. -infinity has to come first. It's the smallest quantity through 5. Does it include 5? No. And why does this get a parentheses? Because it's infinity or -infinity. All right, let's look at number 2. So anyway, this is the answer, right? That's the answer. Number 2, on our number line, we would draw from smallest to biggest, from -2 to 10. We have open or closed circles. We have an open circle, and then we have a closed circle here. And I don't see the word integer, so it's everything between those two numbers. So our smallest number is -2. It doesn't include -2 through 10, and it does include 10, so we get a bracket, and that's the answer. All right, this time we're going to write the set described by. So ignore that 3 for a second. Okay, let's just think of this. All right, so if we had a number line, it says X is between 3 and 4, and it includes 3 and 4. All right. So that would be our answer, except that, what do we have to do with those numbers? We have to multiply them both by 3. So since I don't see the word integer this time, oh, what did I do? Since I don't see the word integer this time, it is a set of numbers, right? And it includes from 3 through, I forgot to multiply. 3 times 3 is 9. From 9 through 3 times 4 is 12. All right, that's it. And then 2n is an integer. So basically it's even numbers, because if you multiply any number times 2, you get an even number, right? So is this going to be a complete set? Couldn't we list even numbers forever? And integers also include negative numbers, right? So we're going to do our ... and say this is not a complete set, but examples of even numbers are these. ... because it's not a complete set. And why didn't we do a range of numbers? Because there's the word integer. It can't include decimals and fractions. All right, so that's 1.1. So when you go to Hawks, so actually let's do that. Let me stop for a second, and I'm going to pull up Hawks. Let me share the screen. So your homework is in Hawks, of course. Let's see. Let me find it. All these tabs are in my way. That's not what I wanted. Yeah, it is. Okay. All right, let's look at your practice problems. All right, so the first one says, I like to read the variable first. That's just me. So X is greater than 13. Now, X does not include 13. And if X is greater than 13, remember that's for infinity, correct? So if it doesn't include 13, and then we're going to use infinity, we got to have 2 parentheses. So I'm going to start with the smallest number, which is 13, through the biggest number. Now to get my infinity sign, I'm going to pull up my keypad, and then this is what I'm looking for right here. So do you notice the parentheses on the right automatically came up? So that means X can be any number greater than 13, not including 13. And that is correct. Yay. All right, let's see what else. X is greater than negative 11. So not negative 11, but any number greater than negative 11. So once again, we're going to the right. So we're going to infinity. Now it doesn't include negative 11. So we're going to have two sets of parentheses. So we'll start off at negative 11 and then we'll go through infinity. All right, now this one says X is between negative 2 and positive 3. Does it include negative 2? It does not, but does it include positive 3? Yes, which means our left side is going to be a parenthesis and our right side is going to be a bracket. So I'm going to find that parenthesis bracket, and this is it right here. And you have to list these numbers numerically, negative 2, comma 3. And that's our answer. All right, now here we have this one. This is an integer. We're going to think of our set of numbers, and then we're going to multiply those set of numbers by 5. Now, since it's an integer, we're not doing a range of numbers. We're doing specific numbers, right? So think of, it can include 0, 1, and 2. Include both of those numbers because the or equal to symbol. So now in our brains, we're thinking of, okay, what is 5 times 0? Well, 5 times 0 is 0. What's 5 times 1? 5 times 1 is 5. And what's 5 times 2? 10. And that's our entire set of solutions. All right, and now you would go straight to certify. So remember, you can practice as much as you want. That's great. I encourage you to practice, but you only get credit when you certify. So make sure you don't forget to do that. All right, let me go back to my PowerPoint. All right, we're moving into 1.2. 1.2, here we go. And we're still on your notes. So two definitions we're going to learn on this section are the words union and the words intersection. So the first question on your practice sheet says, what does union mean? So I want you to write that union includes, or let's start over. All numbers are included. I want you to write that. So union, what does union mean? We're going to write all numbers are included. So what does that mean? So let's say you have a couple of kids and you meet a wonderful man, you're divorced and you meet a wonderful man and he has a couple of kids. Well, when you have a union of your family, that includes everybody, right? Your whole new blended family includes everybody. So when you have a union of sets of numbers, that includes every number that's listed in either set, all right? So for example, oh, and by the way, the symbol, how is it denoted? It's a U without the curly tail, just a happy smile, happy face. So when we see that symbol like this, a U, we're saying that the set -2, 4, and the union of 0, 9. So let's think of these two things as two separate, or we can put it all on the same number line. All right, so let's think of a number line. And all 4 of those numbers that we see, we want to include all of them, and we want to make sure we write all of our numbers in numerical order. So we're going to say from, there's -2, and then I see a 0, and then I see a 4, and then I see a 9. So let's see what that would look like on a number line. So from -2, open circle, through the number 4, and 4 is a closed circle, and everything in between them. So we just graphed the first notation. And then the second says from 0, and then we're going to fill in that circle, through 9, and we're going to fill in that 9 from here to here. So basically, a union is everything that we see on our number line. So we're going to start with our smallest number, which is -2. It's not included, so we're going to start with our parenthesis through, what's our biggest number? 9, and is 9 included? Yes, it is. So that is the answer. It includes everything from -2 to +9. All right, let's look at letter B. So B, on a number line, we want to include everything, right? So we're going to go from -infinity. I see a -1. I see a 4. And I see a positive infinity, which of course wouldn't really be a slot. It doesn't represent a specific number. It just means the set never ends. So from -infinity to +4. So +4 is included. So everything from here to here. And then -1, I'm not filling it in, but it's already included here. And then through positive infinity, both directions. From -infinity to +infinity. So since we're doing union, we want everything included. So that starts from -infinity through forever to the right. So union means everything included. And there we go. All right, so the next word is intersection. So if you're talking about two roads that meet, that would be an intersection, correct? If you say that, I don't know, Hog Mountain Road intersects with Spout Springs Road, you're talking about a specific location. You're not talking about the entire Spout Springs Road and the entire Hog Mountain Road. You're only talking about where those two things meet. So when you have an intersection, that means that, and on your worksheet, this is what I wrote on mine. What does intersection mean? I put numbers that both sets have in common. Numbers both sets have in common. Should I write that? I can't ever figure out where my pen is. Numbers both sets have in common. Not everything's included, only what is in both sets. And do you see the symbol right here? It's an upside down U. That denotes intersection. So if we're looking at a number line, first of all, I like to draw number lines, like I said earlier, so I can see it. All right, so let's draw a number line. So I'm going to make sure all 4 of those numbers are included. -2 in numerical order, 0, 4, 9. So let's graph the first one. So from -2 to +4 includes it includes 4, but not -2. And then from 0 through 9. All right, so since now we're doing an intersection, we only want to include what both sets have in common. So do you see that they have in common from here through here? They only have in common from 0, including 0, through 4. That's what those two sets have in common. Now, those are the same numbers as our union on the first slide or the previous slide, but the answer is much different, right? All right, let's look at letter B. So we have 3, 4, and 9. 3, 4, and 9. So 3 is included in our closed circle through 4. 4 does not get included. And then from 4, open circle through 9. So what did these two sets have in common? Nothing. So 4 is not included in either set. So 4, they don't have anything in common. So basically, we would say that that is an empty set because these two intervals have no elements in common. So you could say null, N-U-L-L, or empty set. There's nothing that is an intersection of both sets of numbers. All right, so here's some that we're going to try. So make sure you draw a number line and write the numbers from least to greatest, include all of them. So we have -10 as our smallest number. So isn't -10 colder than -8 because it's a smaller number? There's -8. It doesn't ask for 0, but I always like to reference 0. And then we have infinity up here, correct? All right, so from -10 to +2, Fill that circle in because the brackets. So we're going to go from here to here. And then from -8 includes -8 through infinity. So we would go this way forever. And now, is this a union or an intersection? Remember, a U is union. Intersection means what they have in common. So where do these two groups overlap? They overlap from -8 to 2. So from -8 to 2, including both of those numbers. Including both of those numbers. All righty. What else? So here we have negative infinity. I see a -11. I see here would be 0. This would be a 3, and this would be a 13. All right, so from negative infinity through 3, including 3. So from, oh, what did I just do? Y'all probably know what I'm doing better than I do. Dang it. Sorry, you guys. All right, anyway, so from negative, oh, I turned my pen off, you guys. Please bear with me. So from negative infinity to +3, everything this way, right? And then from -11, including -11 to 13, not including 13. So this is not a union, it's an intersection. So what do they both have in common? Well, from -11 through 3. That is the answer. I would love for you guys to try the rest of them on your own and then come back and check your answers. That would be awesome. So letter E, we have negative infinity to -11 and then a 7 up here with 0 somewhere in here. All right, so from negative infinity to -11, including -11, so all that. And then -11 through 7. Uh-oh, I went too far. Went too far on that one. Just there. Now this is what? Intersection. So that only includes the number -11. That's it. The only thing these both have in common is -11, and it's only because the -11 is filled in. That's it. All right, here's a union. So we go from -4, I see a 0, I see an 8, and I see a 16. So from -4 through 8 and everything in between, and then from a 0, including 0, through 16, not including 16. So now we have a union. Remember, everything's included. Everything's included. So we go from -4, not included, -4 is not included, all the way up to 16, which is an open circle. So we have parentheses on both sides. Did I skip any? I feel like I skipped some. Oh, I skipped the last one. All right, what about this one? We have -11, we have -3, and we have +6. So we have from -11 to +3, everything in between. And then we have from -3, not included, but we can't, it's already filled in, through 6. So since it's a union, it includes everything from -11 bracket through 6, and 6 gets a parenthesis because it's an open circle. Because of that right there. I hope y'all understand the brackets and parentheses. All right, you guys, I think that's about it. So now what? So your homework for all of Unit 1 is due by, so for my Monday class, everything's due by Wednesday, February 10th. And for the Tuesday class, everything is due by Tuesday, February 9th. However, you guys, if you wait till the end of Unit 1, you're going to have so much homework, you're not even going to know what to do. I'm encouraging you, do not wait. Go ahead and finish these 2 sections tonight. There's also homework on the study skills questions. You'll have to answer questions over how to read a math textbook and tips for success in a math course. And then in order to get your study skills grade, make sure you text me the 2 answers to the remind.com account, and make sure I have your first and last name on that text anyway, however you set it up. All right, so you also have your college algebra 1111 homework as well. So guys, yes, you will have a lot of math homework. Okay, so do not put it off. You need every week, whatever lessons you do in class, you need to do those right away. Don't let them pile up on you. Okay. All right. If you guys need me, please send me an email. I'll get back in touch with you. Make sure when we are live, if at all possible, make sure you join us live as well. Okay. All right, you guys have a great evening. I'll see you later.